September 23rd. This week's code of conduct is to work to OSHA, FRA, and ECI safety standards. Ben, I see that you're on. Is there anything that you'd like to add on the code or any other information you want to share with us while you have us all tuning in?
Yeah, let us know if you have any problems with or any conflicts with these apparent rules so that we can figure it out, because sometimes it's a little gray and we have to figure things out. We have engineers here such as Ken, the Ben Heath, Ben McKinney. There's different people here that can formulate a plan that's workable and safe, that sometimes doesn't always immediately meet some of these standards. I don't know if you have anything to add on that, Ken, but it's an important thing that if you don't think you can, if you think you're in a situation that's iffy, call one of us.
Yeah, and often we can engineer around, issues that create a hazard. Maybe if you're following the rules, we can engineer around it so that hazard doesn't exist.
Yep.
Isolation, elimination through the hierarchy of controls. I like it. So day count up to 96 days without a recordable injury. So excellent job the last 7. Let's finish the week off strong here. With that said, I'm going to pass it over to Austin. He's going to talk about a hazard we have on quite a bit of our jobs, and that's fall protection, especially in the 157 Champlain job. We've been designing a fall protection plan for that, and he's going to share some good training, some best practices with that here. Take it away, Austin.
Come on. All right, so I'm doing fall arrest systems or fall protection today. And these are the ABCs of fall protection. Anchor points, body harness, and a connecting device. Anchor points are a secure point of attachment, whether it's like an I-beam or a concrete form or in a man basket, something that will it can support twice the expected load that's going to be put on it. And you can't use anything that is supporting or suspending a platform. They also engineer devices that are specifically for anchor points. So you can see, they make clamps that clamp I-beams. And you can also choker an I-beam with a strap. They make that. Then they have anchors for concrete. And then for like the peaks of roofs, you can nail in a plate. And then there's your body harness, which is the B. And a full body harness is used. And they're to distribute all the forces across your body, not just in one point. They have a D-ring kind of between the shoulder blades that provide a connection point for your fall arrest system for your lanyard. And they're designed to support a worker. If you do fall and you're waiting for rescue, they're designed to be somewhat comfortable when you're waiting for that rescue. And a body belt, they are not allowed to be used for fall protection. They're just for positioning, because if those create just one point of contact when you fall, and the forces just get put on your waist. So that can create a lot of pain if you fall on that. Some of the connecting devices, shock absorbing lanyards. These are your basics 6-foot lanyards that you'll get from us. Then there's the retracting lifeline, self-retracting. It kind of works like a seatbelt does. If you're slow and controlled move around, it will extend. But if you fall on it or move quickly, it's going to lock up and not allow you to move any further. This is basically, what the whole system looks like set up. You have your anchor point, and your connector, which here is showing, just a choker run I-beam that you hitch one end of your lanyard in to, tighten to that, and, your harness, your body wear. You see the D-ring on the back there that the other end of your lanyard connects to, and then your lanyard is the connecting device, which connects you to your anchor point. So you want to make sure that your anchor point is above you as much as possible, because you don't want to be swinging if you fall or anything like that, because that can cause issues of you, swinging into something else. And your lanyard, it is 6 feet long, but you have to take into account that's a shock absorbing, so it breaks away to 3.5 feet. So when you fall, you have to take into account that it's going to go to 9.5 feet when you fall. Then you have to take into account the user's height and a safety factor, because people are over 6 feet, or the harness is a little loose on them or something like that. Additionally, you want to make sure that your harness is as tight as possible without being restricting. So that's really all I have. Yeah,
Okay.
thank you.
Yeah, awesome. Thank you. Very informative. We currently just purchased a bunch of new harnesses. So if you have a harness that might be defective or looks to be pretty old, please contact Health and Safety, and Austin or myself will take a quick little glance through and probably replace it with some of the newer style harnesses that we have just purchased. So take a look at your harnesses before you deploy them out there in the next couple of weeks, and we got plenty of backup on standby for all that need it.
Sounds good. Thanks,
With
Austin.
that said, Ken, take it away.
Yep, thank you. You hear me okay?
Yes, we can.
Okay. So just, related to what Ben asked me about, engineering solutions for issues and other hazards that might occur when you're trying to comply with certain stuff. I know that last night at AGC, we had a reception last night, and we were kind of just, talking and, socializing, and someone brought up a case where Chinbro, I guess it was, years and years ago, had, I think, 2 fatalities because they were working off an elevated platform lift on a bridge above water. So they had PFDs on, and they were harnessed to their platform, and then something happened where someone jumped in or added weight to the platform. It fell, went into the water, and the platform ended up getting submerged with the guy strapped to it and with PFDs on. And so obviously it was not a good situation. What they ended up doing, the guys after that incident, all the guys who were in that situation would strap knives to their PFDs, so that in the event they did fall in, they'd at least have maybe some chance of cutting their lanyard when they were in that situation, if it ever happened again. But it just shows you that think about the multiple hazards you're going to have and how they combine with each other in situations where you would normally, looking at them in isolated situations, you would be kind of fully protected. But when you start combining situations, you can create a much greater hazard if a certain condition occurs. So let's see, I'm going to take over the screen. I don't normally use this computer, so hopefully it all works well. There, do you see that?
Yes, we do.
Okay. All right, for announcements, we have next Saturday, on October 1st, it's the annual ECI Railroad Golf Tournament. And anyone interested in participating on an ECI team in the Shotgun Scramble should check with Scott Pigeon. And a repeat from last week is the cooler weather is coming, so time to start using diesel fuel supplements. That's the white container. Last week when I posted this, it didn't seem like cooler weather was quite here, but now it's going to seem that way because we're looking at temperatures today. I think today is a high of like 51 or something. I have the link to the wellness plan here. And then here again, the weather, like I said, cooler weather. Today it's saying at 51 and up in the 60s anyway for the weekend. And looks like it's turning showery again. And for this week, we're highlighting the Odell Apartment stormwater repair on Farrell Street in South Burlington, where we were contracted with the Full Circle Property Management to repair a failed 48-inch diameter corrugated HDPE storm line, which had collapsed under the parking lot. The section of pipe crushed between two manholes and required replacement of the entire section. And initially, the owner hired another contractor that started the work and decided it was beyond their capabilities. So the owner then hired ECI because of our ability and our experience working in deep excavations adjacent to existing utilities. Our first task was to identify the conditions and design the supportive excavation and shoring of the existing utilities to establish a plan. The site is located in a parking lot between two apartment buildings. The excavation depth was 18 feet adjacent to the downstream manhole. That was a 7-foot diameter, pretty large structure, CB number 6W. And two water lines cross the excavation along the trench between the two manholes where we were placing the pipe. The first water line was located close enough to the downstream one, the deeper one, that we couldn't fit a trench box into the available space, so we elected to use a combination of steel sheet piles, wood lagging, and haul bar tiebacks to support the excavation around the water line. And then beyond that location, we were able to fit in the trench boxes. So we deployed several crews during this project, including an excavation, piping crew, crane, a sheet pile, installation crew, and tieback drilling crew. And our work identified another downstream section just downstream of that large structure that ECI will be repairing later this season. So here's a plan. You can see on the right and left, there's a building that says where it says residential units. And we're right in between, in the center of the parking lot, there's a storm line that goes down through that double dash line that goes straight through the center of the parking lot. And we were at the two structures between the end of the bottom end of the parking lot there and pretty much midsection. And then the other section that's still as bad is the one that's continuing to the outfall for the pond, so that turns to the right there. Should have highlighted that, make it easier to see. This is when we arrived at the site. It looked like, somebody made an attempt. They had some waste blocks and they just kind of thrashed around and didn't get very far. The first water line is right there, more or less between the two blocks. So we came up with a design. So it was an 8-foot OD, 7-foot ID pipe. There's a large 48 coming in. There's a 48 going out to the left, and another line coming in from the kind of about 2 o'clock there. So because of the space, not much would really fit right. So we used pairs of sheets where we could put in tiebacks, and then the wood lagging or steel plate. We end up with wood lagging, and metal clip the lagging boards to the side of the structure. And then you see where the that line across the trench, that's the water line. It actually had like probably maybe an 11 or a 22 degree bend right there. I think it was a fitting, but there was a bend in the pipe, so it ran parallel, and then it was a jog right across the trench. And we had these short whalers in there. So we had to get the crane out there, the little crane, because there wasn't a lot of room. It's a congested parking lot. We still had traffic going around us and parking around us. And you got the sheets in. And we worked with CWD, Champlain Water District. here you can see one of the important parts about doing any work underground is just making sure everyone knows where that water line is, especially in the case, you know, we knew where it was at the trench, but we had to drill the tiebacks, and you see Dale's there watching, trying to put his head around how he's going to drill the tieback so he avoids that line, because obviously that there's a bend and it's kind of a three-dimensional underground thing to put in your head before you're drilling. And we're typically drill at about a 15-degree deviation from the horizontal, so we're pitched down about 15 degrees, so you can kind of visualize that you're going deeper, but you got to kind of get that in your head and understand where all those utilities are. And they got rolling here. Installed the hollow bar. I don't recall how long they were. They weren't very long because it's not a very deep excavation at that level, beyond that level where we're drilling. And of course, mixing grout. And they got the tiebacks and the whalers and the sheeting in. They were able to start to work their way out and clean up that hole so we can expose the pipe, and then also get it was sized for width to fit a trench box in there between the sheets and the clearance. We designed it for clearance between the whalers. So you see it's fairly wide, but that purpose was to make room for the tieback installation, but also to allow for a trench box to fit in there. So you cleaned up here a little more, got some lagging boards in there, and supported the existing water line and excavated down deeper, added lagging boards as we went. And then there's the first section of pipe installed in our trench, and then ready for the trench box, it looks like, to be dropped in, and to expose that next water line, and prepare and work around that and secure it in place. And here's with the boxes in, another section of pipe in. The second water line is exposed and supported with a steel beam over the top. And then it looks like we just dropped the trench box in and the second trench box, and ready to start laying pipe again. And here's Jacob dropping down in the manhole to do the work from the inside. And that's where we identified the problem going back on the downstream side. And this is a project, an emergency sewer replacement we did in Colchester by St. Mike's Route 15, Limekiln Road there. This was a sheet pile supported excavation, obviously, with a hydraulic whaler system provided by United. I believe it was United. Yeah, it looks like United's product. So there's jack loads into the sheets and put a little pre-stress and allow an open excavation, kind of pretty easy and slick. It involves getting everything squared pretty close, but they're flexible and allow for a little deviation. So that's what I got. I'll turn it back to you, Matt. Everyone have a safe day out there, and dress differently today, maybe.
Yeah, sweatshirts and jackets for sure. Thanks everybody that tuned in. If you're watching a group setting, please just shoot me a message so I can capture full attendance. With that said, let's have a safe day. Let's have a great day.